Hey everyone, and welcome. Today, we're going to break down exactly how you can get full marks on a classic trigonometry graph question from a GCSE higher tier paper. We'll go step by step, so we're not going to leave any room for guesswork. Let's find that perfect answer. So here's our game plan. First up, we're going to decode what the question is really asking. Then we'll solve each part, and most importantly, we'll check our work against the official mark scheme to see exactly how the examiner gives out those precious marks. Okay, first things first, let's really get to grips with what the question is actually asking us to do. We're looking at question 19. It's a classic 3-mark problem, and it's basically a mashup of two key skills, reading a graph and understanding transformations. So this is it, the whole question right here. We're given that familiar sine wave. Part A is worth 2 marks, and it's all about pulling some numbers or estimates right off the graph. Part B, that's a quick 1-marker, and it's a test to see if you get how graphs can shift around. All right, let's jump into Part A. Now the key here, and the question even says it, is to use the graph. So let's walk through the exact step-by-step method you need to do to make that happen. Look, this isn't just a friendly suggestion. This is a foolproof method. Seriously, following these steps, and especially drawing the lines right on your exam paper, that's the clearest possible way to shout to the examiner, hey, I know what I'm doing. Okay, so we've got the method down, but how does that turn into actual marks on the page? To figure that out, let's look directly at the official mark scheme. This is like getting a peek into the examiner's brain.
This is absolutely brilliant. It shows you exactly how easy it is to pick up marks. That first one, the M1, the method mark, you get that just for showing you have the right idea. So by drawing that simple horizontal line at y equals 0.3, you've probably already bagged that first mark without even writing down an answer. How good is that?
And here's something super important to remember. You don't need to be perfectly precise. They know you're just estimating from a graph, right? So the mark scheme is smart about it. It allows for a little bit of wiggle room. Let's see what that range of answers actually looks like.
So to get that final accuracy mark, the A1, you need to give them 2 values. One has to be from that first range, somewhere between 15 and 18, and the other one from the second range, between 162 and 165. Just make sure you only give those 2 answers, no extra incorrect ones, and that second mark is all yours.
Okay, let's switch gears and look at Part B. This is just a single mark question, and it's all about what happens when you start messing with the input of the function, that little bit inside the brackets. Now, before we jump to the answer, let's do a super quick theory refresh. When you add a number inside the function's bracket, like we see here with x plus 20, you get a horizontal shift. Now, this is the bit that catches people out. A plus 20 doesn't move it right, it actually shifts the graph 20 units to the left in the negative direction. A little counterintuitive, I know. So the question is asking, when does sin of x plus 20 equal 0? And honestly, the simplest way to think about this is to just take a step back and ask a more basic question. When is the sign of anything equal to 0? And guess what? The answer is right there on our graph. Yep, if you look at the original sine graph, where does it hit the x-axis? You know, where y is 0. It happens at 3 spots, minus 180 degrees, right at 0 degrees, and again at 180 degrees. Okay, so the logic here is pretty straightforward. That's something inside the sine bracket, in our case it's x plus 20, it has to be equal to one of those 3 numbers we just found. And the easiest one to work with, it's got to be 0, right? So let's do that. We set up a dead simple equation. X plus 20 equals 0. Solve that for x, and what do you get? You get x equals negative 20. And is that a valid answer? Well, it's between negative 180 and 180, so yeah, it's a perfect answer. But hold on, is that the only possible answer? Let's check the mark scheme one last time. This will show us every single answer that an examiner is allowed to accept for this final mark. And there you have it. The mark scheme actually gives 2 possible correct answers. We found negative 20 by setting x plus 20 equals 0. But we could have set x plus 20 equal to 180 instead. If we'd done that, we would have gotten x equals 160. The great thing is, you only need to give one of them to get the mark. This really shows you how simple a B1 mark is. It's totally independent. It's just a mark for the right answer. You don't even need to show your work. Just pop one of those 2 correct values on the answer line and you're golden. All right, we've done it. Let's just take a second to quickly recap the essential skills that we've just nailed down. You know, at the end of the day, this isn't just about question 19. Mastering these skills, reading graphs, showing your method so the examiner can see it, Understanding how transformations work and knowing how to think like the mark scheme, these are absolutely fundamental for doing well across your entire maths paper.
See? When you break a question down like this into its core parts, and you know exactly what the examiner is looking for, you can tackle these problems with a clear plan, a solid method, and just, total confidence that you're going to get every single mark.